example which was to compare when the time quantum is 2 and time quantum is 4. Have you completed that? So can I directly ask the output which one is better according to you? Time quantum 2 or 4 for the given example? I'm getting only one answer. So others have not attempted it or so. See, last class also we spent mostly on solving the examples. We will not have luxury to each time give you so much time. So please try to complete at your home. Sometimes we will do in the class, sometimes you should be doing at your place. So this we are keeping open at the moment. I'll ask in the next class and everyone should be having the answer with justification that why do you think this one is better or why do you think this one is better. Is it okay? Will you be doing in the next class? I mean during this weekend will you be doing so that in the next class directly I can ask you the answer with the reason. ઘરે કરશો બધા એવું પૂછું છું. Okay. Thank you. Thank you. So now let us go for next scheduling algorithm, shortest process next, which is also known as SPN. It is non-preemptive policy. What is meaning of non-preemptive? Once it is started, it will be not preempted by someone else. It will be completed and then only another process will start. So whenever you are making a decision, whenever a process is completed, at that time you check out all the available processes, and whichever process is shortest in time, that you will be giving the first chance. Process with shortest expected time will be selected next. So here we can say that short process jumps ahead of the longer processes. It is one variant of first come first serve in a way, but here we are trying to reduce the bias against the short processes. Here short processes in case of first come first serve. If short processes are at the end, then response time will be too long for that, while here short processes will be attempted first. So here we are trying to reduce the bias which was there in case of first come first serve. So can you tell me which parameter is likely to be improved in case of shortest process first as compared to first come first serve? One parameter will be improved here, which is that average response time will be improved. That is true. Average response time will be improved. Yes. Can you think of any other parameter? Waiting time. What is waiting time? Kushal, in this case, waiting time and response time, will they be same or different? Whenever we have non-preemptive policies, at that time, they are likely to be same, right? Hmm. Throughput, yes, throughput will increase. I was looking for response time and throughput. What is throughput? Do you remember throughput? Because we have been very frequently dealing with response time, turnaround time, and finish time. Throughput means how many processes are completed per unit time. Number of processes, yes, Keval, completed in unit time. So here, more number of processes will be completed quickly. So our throughput will be increased whenever you are dealing with shortest process next. So now let us start doing the example. All of you please note down this table in your book. If you observed, then this is the standard example which we are taking for all the processes, all the scheduling algorithms. So eventually we can compare that. There are 5 processes, 0, 2, 4, 6, 8 is the arrival time and the total service time is 20. This is the example which we are going to solve for all the possible scheduling algorithms. So now let us begin. At 0, I hope you are drawing the time chart. Okay, timeline you are drawing starting from 0, 1, 2, 3, 4, 5, 6, and in the best case at 20 everything should be over. So at 0, which process you will start? In the first time slot, which process will we execute? But E is shorter. See, A is having 3 but E is 2, so should not we start to E? It is not available. Yes, it is not available yet. Arrival time, it is not there. So we will start A. So in the first 3 time slot, you will be writing A. Now, when you are completing at 3, when you are completing at T is equal to 3, how many processes do we have? B. There is only one process. So we don't have any confusion. A is completed. A is completed at T is equal to 3. A is started when T is equal to 0 and it is completed after 3 time quantums. So now we will start B at T is equal to 3. Then when T is equal to 4, then B is having 5 time quantum left and C is having 4. So will we preempt B? No, it is a non-preemptive scheduling algorithm. We don't do that. Once started, we will complete that. So starting from T is equal to T, up to what time, at what point of time B will be completed? When T is 9. Yes, when it is 9. Now tell me, which process will go next? We have completed A and B. E, well done. Because T is equal to 9 means all the processes have arrived. And the shortest one is E. So now it will be time for E. E will be completed at time quantum 11. Then which will be? C. And then E. That is true. So this is what we have just talked about. A, B, E, C, and D. Is there anyone who is having any confusion in this? Feel free to ask me if you have any confusion in this. This is fairly simple. In shortest process next, we examine number of processes present in the queue. Whichever is shortest, that will be served first. So now, if you don't have any doubt, can I have the statistics for this? Response time, average response time, turnaround time, normalized turnaround time, mean turnaround time and mean normalized turnaround time. Please start working for that. Are we done calculating the parameters? Okay, is the voice clear or there is some disturbance here? Okay, fine. So, do you get turnaround time 7.6 and normalized turnaround time 1.84 average? Is this what you are getting? Okay. So, if you can turn the pages and check it with earlier two examples which we have done. Okay. We have done first come first serve, then round robin with quantum 1 and round robin with quantum 4. Compare this with the earlier ones and tell me which is good from average turnaround time. From the point of view of average turnaround time, round robin with quantum 1, round robin with quantum 4, first come first serve, or shortest process next. I hope you are having the earlier examples sold in your book. Would you like to compare at the moment? Ronak, do you have the data of earlier examples? Yes, turnaround time is less in shortest process next. In this example, for this arrival times and this processing time, that is lesser. And what about normalized turnaround time? Can you comment anything on the normalized turnaround time? Can you figure out something? Normalized turnaround time is turnaround time divided by the service time. Or in other words, I can say waiting time plus service time divided by service time. So, are you getting 1.84 in any other or lesser than that or higher than that? How difficult is it to turn the pages and compare? Okay. In first come first serve, you are having 1.74. Fine. Now, what is the difficulty associated with shortest process next? Sometimes you might not know that how much time will be taken by a process. That means either you need to know, if it is already given, then fine. Otherwise, we have to estimate. Otherwise, we have to estimate the required processing time. Once we estimate, yes, that is for sure. Longer process will be, it will be unfair to longer processes, because if short processes keep coming on, then longer process may lead to starvation. It is like opposite of our first come first serve. So if shorter process keeps coming, then longer process will be facing starvation. That is one thing. Apart from that, if the time is not specified, then we will have to estimate that. And when we use the word estimate, our estimation might be correct, or sometimes it might be having errors. If it is errors, that means you thought that this process will be taking shorter time, but it might be taking longer time. Okay. So read this for a moment. So one is already what you have said, possibility of starvation for the longer processes, which you have already said. So how do we estimate? That is given in first 2 points. If it is interactive process, then operating system can keep a running average of each process, that this one each time when it interacts it is taking 4 seconds, then 4.5 seconds, 4.25 seconds, and so on. So with us, I mean, of course, this is very unrealistic high time. When I'm saying 4 seconds, it is not going to be that, but I'm just using that for an example. So accordingly, it can assume that this process will be is going to take so much. The another approach could be to gather statistics. If the same job is running frequently, like if you are asking to open a file, word file of this particular size very frequently, then based on the past experience, we can find out what could be the estimated time. So now I want you to attempt the first example here and the second at your place. The first example, please do it now, and the second one afterwards in the assignment. Start working, and whenever you are done, kindly let me know. So can you just tell me the sequence? The first process which will be executed, I think, is going to be A. Will the first process be A? Okay. A, C, B, D, and E. Okay. So how did you decide that when you are having 9 and 12, I mean, when D and E, both of them are having 5, then how did you decide the priority? Yes, based on the arrival time. Right. D is available at, no, D is available at 9. D is available at 9. Anyway, that case is not present. That is what you are saying. Okay, let me count. 3 and 5. Acha, D. Oh, okay, got it, got it, got it, got it. Huh. In case, okay, in case if it was present, if here 10 was there, then also you would count D and E. Unless specified otherwise, whenever processing time is same, then the breaking criteria would be the arrival time. If they are the same, here there is not the problem. Okay, here there is not the problem. Anyway, what is the response time for A, B, C, D, and E? Can you please write all 5 together, response times for this, so we can verify answers from each other? Is it 0, 4, 0, 1, 4 or 3, the last one? Ronak, could you please check? I think majority of you are saying 0, 4, 0, 1, 3. So I think that should... No, Priyank, I'm asking the response time. Priyank, could you please check again? Okay. And what is the turnaround time for A, B, C, D, E? Can you please write all five with space? 3926. Great. All of you are getting the same answer. I suspect whether you are already having a parallel group and then sharing your answers there. Okay, I'm just kidding. I'm glad that all of you are getting correct answer, assuming that this is the correct answer. And similarly, you can find out average turnaround time. Then I'm not asking you normalized turnaround time. I'm sure you can calculate that. And please note down this example. I want you to do at your home. Kindly note down this example. Acha, is it 5.6? Keval, what is 5.6? Average turnaround time? Okay. Others, are we getting 5.6? Great. And normalized turnaround time, is it 1.32? Okay, perfect. Then please try to do it at your home. Don't be lazy. It will not take you more than 5 to 10 minutes. Try to do it. Once you have noted this down, let me know. And if you have no doubts in shortest process next, we will go ahead with the next similar and slightly different scheduling algorithm. Is this one clear? Shortest process next. Okay. Then the next algorithm, I'll show you the comparison table at the end. I don't want to show that at the. Is the screen visible or there is some issue here? Is it visible? I think it is stuck here. Okay, fine. Probably it is anyway. So let us go for the shortest remaining time, SRT. Okay. So in the shortest process next, whenever any process is given execution time, unless it is completed, it will be having the processor. While in case of shortest remaining time, this is the preemptive version of shortest process next. So after decided time quantum, if we decide that after each clock cycle, after one time quantum, we are going to give chance to another process. Then we will check that which process is having shortest time left to be completed now. So it is preemptive version of shortest process next. The process with shortest remaining processing time. Total processing time could be 10. But if only 2 is left now because 8 has already been executed, then it will be considered 2. And if a new process is available which has not been executed, which is having time 3, then 2 will be given priority over 3. So of course here we must estimate the processing time and then choose the shortest. So let us see here. We are going to work with time quantum 1. I don't want you to see that. So I'll come here. Okay. Just look at this. Our standard example 0, 2, 4, 6, 8. And these are the times. So in the first time slot, time quantum which you are assuming here is 1. If time quantum is different, the calculations and the running of processes will be different. So initially in the first time quantum from 0 to 1, a time is equal to 0 to 1, A will be given the priority. A will be executed. Then from 1 to 2, can you tell me which one will be executed? A, because there is no one else. So now you will also keep account that whenever T is 2, at that time A is having only one processing unit left. It requires only one processing time. and now B is available. B requires 2. So which one do you think should we give first priority to, A or B? A. Perfectly. We will go for A. Then A is completed. So A will be removed from the queue. At T is equal to 3, how many processes are in the ready queue? One process, and that process is B. So should we execute B now? Yes, let us do it. So you will give chance to B. At T is equal to 4, we have another process available. Now we have B and C. B is having 5 time quantum remaining and C is having 4. So C, yes, that is true. All of you are right. So now can you please complete this example in your book? Please let me know whenever you have done the timeline as well as calculated statistics which you have been doing so far. Okay. Okay, well, let us wait for a few more duns. You may please calculate average of all of them as well. Okay. Can you tell me the response times for A, B, C, D, E? Finish times or complete times? Three, then 15, then 8, 20, and 10. That's correct. Okay. Then turnaround time for A, B, C, D, E. 3, 13, 4, 14, 2. Okay. Uh, Are you all getting the same timeline or do you have any other activity? So it is a nice practice in this case to write down that how much units are left. So it will be easier for us. Rather than keeping in mind, you should scribble it on the side. So turnaround time is 7.2 and normalized turnaround time is 1.59. Is it better than, at least for this example, we are not comparing in general. For this example, is it same as shortest process next or shortest remaining time is good? Which one is better? So to answer this, what should you do? You should go for the average response time, average turnaround time, average normalized turnaround time, and then try to look at this. So will this remove the problem of starvation in case of long processes? In the shortest process next, the long processes were likely to be starved. If short processes kept coming in, then longer processes may face starvation. Will it continue here or you think we have overcome that? Somewhat means yes, it is still there. It is still there because here we are shortest remaining time we are considering first. Okay. So if the long process was already initiated and it was executed and now only lesser time is remaining, then that is another issue. But if you have keep flow of the shorter processes before the longer one was attempted, then it will still be problematic. Now again, can you please do the first one so we can compare with the earlier example and this you will do at home. Time quantum, let us take one only. Okay, time quantum, we are taking one only here. Unless anything is mentioned, by default, on each clock cycle, you will be examining that how much time is left in each process, and then you will be deciding the priority. I don't know, Ronak. I haven't calculated it. So let us wait for all of you getting same as the earlier one. Can you get me the timeline, please? Like in the first time you are having, can you write first 5 time slots? A, B, A, C, and likewise. Which jobs will be executed in the 5 time quantums? Can you write that? First 5. Okay. Is it A, C, C? Yes. Then next 5. Okay. Then next. Okay. Keval has given us this. No process is preempted in this case. Is it so? Okay, then this is same as, it happens to be same as the shortest process next. will all the parameters be same or some of the parameters you think might be different? If the timeline is same, all the statistical parameters, will they be same or slightly different? Same, of course, it is going to be the same. It will be identical. So now it doesn't serve the purpose. So this one, can you please solve the next example? Because here I think we will be having preemption. So can we please solve this one? This is also fairly simple problem to attempt. Okay. So response time for A, B, C, D, E. Zero 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 eight. That's correct. Yes. And turnaround time for A, B, C, D. Okay. Listen to the question, please. Can your turnaround time be lesser than processing time? Can turnaround time ever be lesser than processing time? No. Can response time lesser than processing time? Yes, could be. Right. They are unrelated. We cannot comment like that. Yes. Okay, fine. So, this one. And now, uh, what is the average normalized turnaround time in this case? Average normalized turnaround time? Once we get 2, 3 answers, we will conclude. These two are slightly different. Do not support Yash because he is your friend, right? Only if you are getting that answer. Ronak, can you please check once again? Devansh, can you provide me individual turnaround times so Ronak and others can check that where their answer is different? Okay. 1, 1.11, 1 and 1.88. Keval is getting 1.89. Have you rounded off, Keval? Okay. So, Ronak, are we getting this? Ronak, you come with another answer now. So, what we'll have to do is, it is 4.99 divided by, it is 1.61 instead of 1.88. Okay. So, for the last one, can you tell me what is your turnaround time and what is the service time? For D process, what are you getting as turnaround time? Others, are we getting 17? So 17 divided by 9. What is that? 17 divided by 9. Is it okay? That's fine. So now I would like to go to the table which you have skipped. This we will do next time. Let us have a look at the table. So we are comparing these three. First come, first serve, round robin, and shortest process next. Selection function in case of first come, first serve is waiting time. Here it is constant. There is no selection function. And here minimum of the service time. S is the service time. Minimum of the service time. That is what we are talking about. Then decision mode. Then round robin is preemptive. And SPN and FCFS are non-preemptive. Throughput in as you said, in the shortest process next, it is going to be high. So in round robin, that depends on the time quantum, that what time quantum we are choosing. And here in first come first serve, that is not a parameter to be measured. We don't emphasize on that. Response time, it will be high, especially when the longer processes are ahead of the shorter processes in the queue. The round robin, here we will be having the good response time. In short process next, for the short process, response time will be good. So here actually, good response time for all the processes. Do you agree with this? In round robin, not just for the short processes, but for all the processes, response time is good, isn't it? Yes. While here this is true, that for the short process, the response time will be good. Overhead is minimum in this one. It can be, is it minimum here or it can be high here? In round robin, it can be high. Yes, it can be high in round robin. And here, it is minimum. Do you think can be high here? Overhead again. Overhead means how much time we are consuming in switching and how much time we are consuming on the actual activity. So whenever there is more context switching, that means overhead will be higher. So in round robin, one by one, we are switching the jobs. So some time we are going to consume not in the execution, but in the management. So here it would be high. And here, what do you think? What should I write? In the shortest process next? Minimum. Yes, it is minimum. Effect on the processes. It is penalizing the short process and IO bound process. Do you agree with that? First come, first serve. Then IO bound process will be penalized as well as the short process. Is it fair treatment in round robin, everyone? Yes. And the last one, long processes can be penalized in case of shortest process next. Starvation. In first come, first serve, there will be no starvation. Okay, like, because see here, if the short process is coming at the fourth place, then it will be executed. Okay, it will be executed, but after some time. Effective normalized turnaround ratio will be high for that one. But in first come first serve, whenever your turn will come, you will be handled, you will be executed. In round robin, of course, there is no question of starvation. While in shortest process next, if your time quantum is 20 and all the processes lesser than 20 keeps coming in, then starvation is pretty much likely for the long processes in case of shortest process next. So in case of starvation, FCFS is better than SPN. Do you agree with that? If we compare the first and the third one, then longer processes are more likely to be starved in case of shortest process next as compared to what short processes will be facing in case of first come first serve. Yes. Okay. And round robin, there is nothing like starvation. Now I would like you to add here one column in your book or just think in your mind about shortest remaining time and then try to think about all these parameters. So what will be the selection function? Minimum remaining service time. Yes, minimum remaining time. That will be the function. What will I write in the decision mode? Preemptive. Yes, it is preemptive. Throughput as high as shortest process next. If we compare shortest process next and shortest remaining time, no, but it will be better than FCFS in most of the cases. Again, that depends on the arrival time, the processing time, etc. But in general, we can intuitively say that throughput would be better than FCFS, but it might be lower than SPN. Do you agree with that statement? If you don't respond, then I wouldn't know whether you agree or disagree. Or you are indifferent to this statement that you don't care, let it be higher or lower. How does it matter to us? Is it so? Okay, let me repeat the statement. What I'm saying is, in case of shortest remaining time, throughput might be higher than first come first serve, but it is likely to be lesser than shortest process next. And see, this is not universally true always statement. It will not always happen so. That depends on the data. But in general, intuitively, we can make a statement like that. If there is always possible to generate one example where FCFS will be producing better throughput than the next one. There is a possibility of that. And but in general, we can say that. Now response time. What should we write in the response time? Shortest remaining job. Good response time for short processes. Or we can say that longer response time or high response time for long processes. That can also be said. What about overhead? Overhead? Overhead can be high. Yes, overhead can be high because we are involved in switching. So it is certainly higher than shortest process next. That is certainly higher than that. But in general also it can be high. Effect on the processes? Which type of processes might have an unfair treatment? Long processes, especially when if the short processes keeps coming in. In that case, we will have a trouble. And starvation? Is starvation possible? Yes, possible. possible. When? Can you tell me when there is likely to be starvation here in shortest remaining time? Same as SPN, like if you have short processes keep coming in, if you have short processes which are continuously coming in, then the longer process will have to wait and that might feel starved. Is it fine so far? Okay. So there is one example pending which I would request you to do in the assignment, and I'm ending the class. Thank you.